Now that we have gone through what arithmetic sequence and progression is, and if you still haven't, I suggest you going through the previous video to understand what really sequences and progressions are about. Now, let's move on into a geometric sequence and progression. Now, look at this sequence. What do you notice between them? Well, if we apply the arithmetic way of looking, we will say that, oh, this is plus 6, but then this is plus 18, and so on. It doesn't make sense. It doesn't have the same constant. But there's another way to look at it, and that is a geometric way. And that is, okay, when we see, okay, 3 to 9, what do we do? Well, we multiply by 3. 3 times 3 is 9. 9 multiplied by 3 is 27, and 27 multiplied by 3 is 81. In the case, we call it common ratio. Okay, let me write it out in a complete sentence. Well, in geometric progression, we use there is a common ratio, often denoted as R, between each term of the sequence, or you can say series. In this case, how do we find the common ratio? Well, we take the second term divided by the first term. In this case, 9 over 3, we get 3. That is our R. Alright, now, given that we want to find, let's say this is, let me use a different color. This is first term, second term, third term, and fourth term. Given that we want to find the fifth term, not the fifth term. Let's say we want to find the 30th term. Right? How do we find? Well, of course, we don't want to multiply them one by one. It will take too long. Very simple, actually. We take the first term, A1, then we multiply by the common ratio to the power of n minus 1, where n equals number of times. Or you can say term as well. Well, how? So in this case, the 30th term is A1, 3, multiplied by the common ratio, 3 to the power of 30 minus 1. In this case, we will get quite a huge number, actually. But okay, let me change this. Let's put this at 15. Alright. 3 multiplied by 3 to the power of 15 minus 1. You will get 14348,907. Very big number. Alright, but this basically means that we add up. This is the one we multiply. Sorry, not add up. One we multiply so many times, 15 times. The 15th term will be this number. 15th term. But let's say we want to find the sum of the first, let me make a smaller number, first 7 terms, right? How do we find the first sum of the first 7 terms? Also very simple. Unlike the arithmetic sequence, you don't need to find the last term. All you have to do is to apply this formula. A1 multiplied by 1 minus r to the power of n divided by 1 minus r. Okay, how do we apply in this case? A1, 3, multiplied by 1 minus r, the very common ratio of 3, to the power of n is 7 in this case. 1 minus by our ratio 3. Okay, and put that into your calculator. And your answer is 3279. This basically is the sum of all of the first 7 terms of the sequence. Or you can call it a series then. The series. Right, let's move on to example questions. Here, determine if the sequence is geometric. If it is, find the common ratio, 8 term, and the explicit formula. Okay, for question 1. Right? Is it geometric in the first place? Now let us take A2 divided by A1. -3 divided by -1. We get 3. Then we take this third term divide the third term, -9 divide second term, -3, you get 3 as well. So the common ratio is geometric and the common ratio is 3. Multiply by 3 each time you go on in the sequence. And okay, at 8th term, okay, 8th term, of course, for the formula A1 r power n minus 1 equals to A1 first term -1 3 power of n minus 1 to 8 minus 1. In this case, you get -2187. Second term, now we want to find if it's the common ratio, right, or geometric. So we take A2 divided by A1, 1/2 divide over 2. We take 1/4. Then we try to test 1/8 over 1/2. Also 1/4. That means the common ratio is 1/4 and it's geometric actually. So we want to find 8th term. Right, the 8th term, the first term r n minus 1 equal to first term is 2, ratio is half, power of 8 minus 1, you'll get 1/64. That is that simple. I mean the explicit formula, I won't be going over it because I've gone over it, how to do it in the arithmetic sequence video, and it's pretty much irrelevant to this current topic, right? And okay, now let's just move on to the question 9. 9, okay, find the missing term or term of the geometric sequence. Now this will be a bit challenging, but let us remember that always the formula for the term. Okay, let us write this as 4108, right? What you will notice that even though there are terms before and after this, now all we need to know is this x and y, right? So in this case, let us denote this as A1, A2, A3, A4, right? So A1, A2, A3, A4. So now that we know, of course, now let's rewrite the formula, right? A1, R, we don't know the ratio, so we cannot find. So what we want to do is to find out the ratio. So we know that the term, so A4 equal to, let me use the white color again, A4 equal to A1 r to the power of n minus 1, right? So in this case, what is our n? What is our a4? 1 over 8 equal to a1, 4, r. What is our n? Okay, our n, is 4. The number of times, right, is 4. So 4 minus 1 equals to 3, of course. And then we can use basic algebra to find out that, well, r equals to 1 over 8 over 4, the cube root of 1 over 8 over 4, which is 3. So we found our common ratio is 3. So therefore, our A2 equal to, well, 4 multiplied by 3, 4 multiplied by 3 equal to 12, and A3 equal to 4 multiplied by 3, 12 multiplied by 3, we get 36. And if you want to confirm, let's take A4, which is 36 multiplied by 3, 36 multiplied by 3 is 108, and that is your two answers. Right, now moving on. Question 10. In this situation, we can use back the same logic, right? This is A1, A2, A3, A4, and A5. Now, we want to find, okay, we know that A5 equal to A1 r n minus 1. So A5 negative 1 over 25 equal to negative 25 r n minus 1. Well, this is 5 minus 1, so if 5 minus 1, well, it is 4. Now, very simple. We just apply the fourth root of negative 1 over 25. Of course, divide by negative 25. I wanted to put it in one equation, so it's a bit more complex, but it's fine. Then you slowly find, if you type it in the calculator, 1 over 25 divide by negative 25. Okay, my bad. One over 5, the common ratio is 1 over 5. So in this case, now that you have the common ratio is 1 over 5, well, A2 equal to negative 25 multiply 1 over 5, negative 5. A3 equals negative 5 multiply 1 over 5 equals, well, negative 1. A4 equals to negative 1 multiply 1 over 5, when negative 1 over 5. And you just want to confirm A5 is negative 1 over 5 multiply negative 1 over 5 multiply 1 over 5 equals negative 1 over 25. And that is your answer. Now, we want to evaluate each of the geometric sequence described. Right? In this case, evaluate means add up or sum of all terms in the sequence. Right? In this case, for question 11, okay, we know the first term is negative 3, then 15, then negative 75, then 375. First, we want to find the common ratio, which is 15 divided negative 3 equals 15 divided negative 3, negative 5. Then we have to confirm that the common ratio is negative 5 by taking negative 75 divided 15, which is negative 5. Common ratio, correct. So we will be doing it for n equal 8 times. We will be doing it for 8 times. And then remember that our formula for the sum of a number of terms. So sum of the 8 terms equal, because n is 8, A1 1 minus r power of n divided by 1 minus r. In this case, A1 negative 3 multiplied by 1 minus r by the ratio -5 power of n is 8, 1 minus -5, and in this case just type it in your calculator. Number should be 195312, and that is the sum of the first 8 terms of the sequence. Moving on, 13. We get A1, first term is 1, ratio equals 4, n equals 7. Back to the formula, sum of the first 7 terms equals to A1 r 1 minus r power n 1 minus r equals to 1 minus r is 4 power n 7 divided by 1 minus 4, and you will get 5461, and that is your final answer. Finally, something related to economics. Alright, so the government through a subsidy program distribute $5 million. If you assume that each person or agency spends 70% of what it receives and 70% of this is spent and so on, how much total increase in spending results from this government action? Now, let's assume, let's write this out as a sequence, 500,000, 5 million, then 70% multiplied by 70%, well, multiplied by 0.7, you get 3.5 million. Then we multiply by 0.7 again, you get 2.45,000,000. Yes, 2.45 million, and so on until the amount gets to 0, right? So, but here in this case, we don't know how many times until it goes to 0. How many times it multiplies? So, but first, let us list out the A1 equals to 3500 as given in the question here. Now we know our common ratio is 0.7, and then we don't know the sum of numbers. I mean, it's basically infinity, right? Basically until it ends. So now let us look at this way. Remember that the sum of a certain number is A1 1 minus r power n 1 minus r, right? I suppose that you have learned limits before, and if you haven't, I shall be making a video on it soon. But let's say the limit as n approaches infinity, right? As A1 1 minus r n 1 minus r. What happens if this becomes a very big number? And thus 1 minus a very big number, and say your ratio is 5. Okay, very big number, we can cancel out and we will get A1 1 minus r. Okay, so in this situation, the sum as it goes to infinity, A1 3500,000, because we cancel this out, 1 minus r by our ratio 0.7 equal to 1166666.67. Well, this is about almost $12 million will be spent And that is your final answer.